The world of geology is greatly affected by radiation. Looking at quartz, we see that it's nice and clear. To the naked eye, there's no impurities, and we can see right through it. But there are subatomic purities in here. These impurities can range from different elements. The most common is iron. Now this iron plays a huge part in it. Looking at its close cousin, amethyst, we see that there's a huge difference, even though they're almost exactly identical. The difference between quartz and amethyst is amethyst has been irradiated. This irradiation process happened from uranium decaying into potassium-40 or thorium decaying into potassium-40. This potassium is found around the soil that the amethyst is in. This causes irradiation of the amethyst, changing the iron from a 0 oxidation state up to a +4 oxidation state. This oxidation state can greatly affect the colors produced. Aquamarine, citrine, and amethyst are exactly the same chemically, but the oxidation states are much different. Aquamarine is in the +2 oxidation state. Citrine is in the +3 oxidation state of iron, and amethyst is in the +4 oxidation state. Taking a look at this sample first, we see the top is much like the quartz, white and pure. But flipping it over, we see there's a section of aquamarine and amethyst. This could have been caused by where it was situated in the mud, where the aquamarine was located farther away from the radiation source and the amethyst was closer, allowing the amethyst to be oxidized more than the aquamarine, but also leaving the quartz in the back untouched. Another quartz mineral that is affected is known as smoky quartz. This smoky quartz doesn't have the impurity of iron, but has the impurity of aluminum. This aluminum, when irradiated, causes it to give a smoky black color, referring to the name smoky quartz. Irradiation doesn't just play into minerals, it also plays into glassware. Some glassware, such as amber brown glass, could have been just regular clear glass, but underwent irradiation. Amber brown color is caused by lead, around 20 to 30%, being exposed to large amounts of radiation, around 1 megarad or 1 million rads. Another glass that's affected is purple glass that almost has the same color as amethyst, even though it doesn't contain iron, but it contains manganese. This manganese, when exposed to ultraviolet light or radiation, causes it to turn the dark purple, almost amethyst color. This color change is achieved by exposing it to either electron beam or a cobalt-60 sample, which outputs huge amounts of gamma rays, and electron beam outputs huge amount of electromagnetic radiation. Now this irradiation of this glass could be a good thing, allowing you to produce these vibrant purples and these nice amber brown colors, but it could be a problem for glass collectors looking for authentic colors in glass. A paper written by Mark Javinka on irradiation changes the color of glass says, "Why would anyone want to alter the color of antique glassware? Let's look at some examples. A lowly glass telephone insulator, for example, in common clear or aqua, sells for $1 to $4. This very same piece, in unusual colors, say orange, can sell as much for as $50 to $75. Common mason patent in 1858 fruit jars in ordinary colors sell for under $10 each. At a Chicago bottle show, a lot of 3 of those same jars in an unusual amber brought $1,000. A clear frosted Louis Chauveau vase generally sells for $2,000 to $3,000, and in deep purple, the same vase sold for $20,000. In each of the cases above, refunds were made because the glass was later proved to be irradiated. A souvenir from the American Museum of Atomic Energy, Oak Ridge, Tennessee, used this principle of irradiation of glass to change color. Printed on the package, colorless before irradiation, amber after exposure to cobalt-60 gamma rays, purple producing by heating amber specimen. Specimens are not radioactive. Irradiated by Oak Ridge Atomic Industries, Inc., Oak Ridge, Tennessee. MFGD by Timecraft, Oak Ridge, Tennessee. Thanks for watching and see you next week. If you have any questions pertaining to the video, post them down in the comment section below. I'll be more than happy to answer them.